For the last section, we are looking at applications. And the steps that we want to go through is first draw a picture. Anytime you can draw a picture, it's easier to figure out what's going on. Label the triangle given that information, and then and solve the equation to find the missing side or angle. So the first one, we have a ladder that's 500 centimeters long, which is pretty short, leans against a building. If the angle between the ground and the ladder is 57 degrees, how far from the wall is the bottom of the ladder? So we have the ladder leaning against the wall, and it's 500 centimeters. That's how long this ladder is. And the angle between the ground and the ladder is 57. And what we're looking for is how far from the wall is the bottom of the ladder. So this is what the missing piece that we're looking at. So which trig function would relate that? I have an angle, I have the adjacent side, and the hypotenuse. So that has to be cosine. And we're going to round our final answer to the nearest tenth. So we get cosine 57 equals x over 500. Now to solve this, I'm just going to multiply both sides by 500 and plug that in the calculator. So 500 cosine 57, round it to the nearest tenth. I get x is 272.3, and the units here were centimeters. Number 2, two sides of a rectangle are 25 and 8 centimeters. What is the measure to the nearest degree of the angle formed by the short side and the diagonal of the rectangle? So the short side and the diagonal would be that angle. So I'm just going to put my 25 down here. So this is a triangle. We get a right triangle in here. So I want to find that angle, and I have the opposite side and the adjacent side. So tangent of x is going to be opposite over adjacent. So 25 over 8. And to find it, remember, we have to do the inverse. So we have to do the second function tangent of 25 over 8. So second tangent, and you see that tangent to the -1 comes up. 25 divided by 8. Close it, and we get 72.25, and we want to round to the nearest whole degree. And that's just going to round to 72 degrees. Number 3, a kite is flying 115 feet above the ground. The length of the string to the kite is 150 feet. Find the angle to the nearest degree that the string makes with the ground. So we have our kite up here, and that distance is 115. And then we have a string that's 150 feet. And what we want to know is the angle the string makes with the ground. So this angle is what we're interested in. So I'm looking at this angle. I know what the opposite side is, and I know what the hypotenuse. So therefore we're using the sine function, is opposite over hypotenuse. And to actually find the angle, we have to use inverse sine. So second sine 115 divided by 150. And we get 50.05. And again, they're asking to the nearest degree, so it's going to be 50 degrees. We have an observation tower 75 meters high. A support wire is attached to the tower 20 meters from the top. So this distance here is 20. The support wire and the ground form an angle 46 degrees. So here's the ground, so therefore this angle is 46. What is the length of the support wire to the nearest tenth? So that's what I'm interested in. Now, even though this whole thing is 75, but the support wire is 20 down, so this distance is actually going to be 55. So when I go to set it up, I'm going to redraw my triangle because there's too much going on. So again, I have an angle, the opposite, and hypotenuse, so it's sine again. So sine of 46 equals 55 is the opposite over x. This time I know my angle, so I'm not going to have to use the inverse. I only have to use the inverse when I don't know the angle. So multiply both sides by x. And this gets it out of the denominator. And then I'm going to divide both sides by 46, by sine of 46. So in my calculator, I just have 55 divided by sine of 46. And I get 76.4589, and we want it to the nearest tenth. So 76.5.